take a look at section 11.1, and we're going to be solving system by graphic. So what a system is just two or more equations and a solution to a system is just an X and Y combo that works in all equations. There's actually three types of solutions for these, and then I'll show you some examples. So the first type of solution is if it's just a single point. And the answer would just be where they cross. Something else that could happen is you can get the same line. And the solution would be literally every point, because it's the same slope and y-intercept. And then the third type of solution is just no solution. And these would just be parallel lines that have the same slope and different y-intercepts. So I have three types of examples. The first type is I'll ask you to determine if each ordered pair is a solution. And let me show you. First system is x plus y equals 7. And then we have 2x plus 3y equals 19. And we're going to check to see if 1,6 is a solution, and we're going to check to see if 2,5 is a solution. And the way you figure out if they're a solution is, we said before, it's an X and Y combination that works in all equations, right? So what we're going to do is let's plug in 1,6 for X and for Y, and let's see if it works for all the equations. For the first one, 1 plus 6 equals 7. So it works for the first equation. Let's try the second equation. 2 times 1 plus 3 times 6 is 19. 2 plus 18 is not 19. So this is not a solution. It would be a solution if it worked in both. Obviously, 2 plus 18 is not 19, so that wouldn't work. Let's try 2,5. We're going to try this when x is 2 and y is 5. So if we do 2 plus 5, that is 7, so that makes sense. And then the second one, 2 times 2 plus 3 times 5, 4 plus 15 is 19. So it looks like it works in the second equation. So I would say at this, yes, it is a solution. The way we show a system is we use this like squiggle line thing here. Some people call it curly brackets, but that's how you show that two equations are in one system. Okay. So that's the first type of example. And second type of example is, what if I asked you to find the solution? By graphing. Easiest way to graph these lines is to get, we actually have two ways to graph. One way to do it is in slope intercept form. So slope intercept form would be y equals mx plus b, where m is our slope and b is the y-intercept. We talked a little bit about slope and y-intercepts. Just as a refresher, the slope is usually a fraction that's either top tells you whether you go up or down, the bottom tells you whether you go right or left, depending on if it's positive or negative. So we can graph lines by finding their slope. We could also graph lines by finding their intercepts. Now, an intercept is just where the line crosses an axis. The way we get an x-intercept is we make y equal to 0. And the way we get a y-intercept is we make x equal to 0. What I'll do is I'll show you a few examples. Generally, the way that I prefer to graph is by getting the intercept. I think that's just easier. So let me show you. What if I gave you a problem where it's x plus y equals 8 and x minus y is equal to -2? And that's one system. I'm going to go 10 units in each direction. And then I'm going to graph by finding the x and y intercepts. So I'll graph this line in red. The easiest way to graph that, to get the x-intercept, all you have to do is you just put 0 in for y. So we just get x is 8. And then we could get the y-intercept by putting 0 in for x. And you just get y is 8. Connecting our intercept gives us that line. The second line, x minus y is equal to -2. The way you get the x-intercept is you make y 0. You plug in 0 for y, you just get x is -2. And to get the y-intercept, plug in 0 for x. And you just get y is equal to 2. So I put this in the wrong spot here. X would be -2 is right here. Y would be 2 is right here. We should always label our intercepts and then connect the intercepts. So as far as what's the solution would be wherever they cross. And when we graph, sometimes we just kind of have to estimate where it is. It looks like for this, it's maybe 1, 2, 3, 4. And maybe 1, 2, 3, 4, 5. It might be 3, 5. But the problem with graphing is you kind of have to estimate it. And we're going to learn a technique in the next section, the last one for the night, where we can figure out exactly where it is. I think this one would probably be 3, 5. Just because if we plug them in, 3 plus 5 is 8. And 3 minus 5 is -2. All right, so my graph was close. But on the test, if I ask you to solve by graphing, it doesn't have to be exact. We'll do one more of these. What if we had x plus y is equal to 1 and x plus y is equal to -3? Do the same thing we did before, graph them by finding the intercepts. Graph this first one in red, so x plus y is 1. Where we get the x-intercept is we make y 0. And we just get x is 1. The way you get the y-intercept is you make x 0 and y is 1. The line would look something like that. Second line, x plus y is -3. Where we get the x-intercept is we make y 0. Where we get the y-intercept is we make x 0. If you put 0 in for y, you get x is -3. 1, 2, 3 is right here. And the y-intercept would be -3. My graph isn't perfect, but these lines aren't supposed to cross. They're supposed to be parallel. So we just said there's no solution because the lines are parallel. We want to try to show you one more of these here before we do the last type. What if we had 4x plus y is equal to 0 and 5x plus y is equal to 2? And the reason why I wanted to show you this, let's graph the first one right here. So 5x plus y is 2. The x-intercept, we put 0 in for y. We just get 5x equals 2, so x is 2.5, or 2 over 5. Maybe over here somewhere. To get the y-intercept, you put 0 in for x. And you just get y is 2. Problem is when we go to graph this other equation, 4x plus y is 0, you get the x-intercept is 0, and also the y-intercept is 0. So you can't really graph that line because you need 2 points to graph a line. You can't just use one. So we could do this a couple different ways. One thing we could do is we could make a table and plug in. The other thing we could do is graph this in slope-intercept form. So one thing we could do is take 4x plus y is equal to 0, bring the 4x on the other side, and then graph this in slope-intercept form, where this is our y-intercept and this is our slope. So we'll start at 0 and then go down 4 over 1. And it looks like we get another line like that, where just by graphing it roughly like this, there's no solution. My purpose for showing you this example was if you get x and y intercepts of both 0, what you want to try to do is then write it in slope-intercept form and graph from there. Now, the last type of examples I want to show you are, I'm going to ask you without graphing, decide what the solution looks like. So what I mean by this is if there are different slopes, this just means that there's one solution and there's one point. If they're the same slope and the same y-intercept, this means that they're the same line. And then if it's the same slope and different y-intercepts, this means that there's parallel and there's no solution. The way you get the slope is we could just convert to slope-intercept form. meaning y equals mx plus b. And this is your slope and y-intercept. I'll just give you a second to copy that down, and then we'll take a look at maybe a couple examples before finishing things up. So if we're going to convert to slope-intercept form, take 8x plus y is equal to 17, and just get the y by itself. You just bring the 8x on the other side. You get y is equal to negative 8x plus 17. If you take x plus 6y equals 6, you get the y by itself. First thing we have to do is get rid of the x and divide by 6. You get y is equal to negative 1/6 x plus 1. So it looks like the slopes are different. So it's just 1 point. We don't have to graph it. As long as the slopes are different, they intersect at 1 point. One more. What if we just had 3x plus y is 0 and 2y is equal to 4 minus 6x? Let's take 3x plus y is 0. We'll get the y by itself. So our slope is negative 3. And the other line, 2y equals 4 minus 6x. We'll divide by 2. We'll get y is equal to negative 3x plus 2. So it looks like they have the same slope and different y-intercepts. These lines are parallel, no solution.